In this question, we're asked to fill in a table of xy coordinate points for respective quadrants. Now, in another version of this question, it just asks you if the sine is positive, the cosine is negative, what quadrant are we in? Okay, so there's actually two questions that I'm talking about here at once, but they both have the same idea, which is if sine of theta is positive, for example, and cosine of theta is negative, what quadrant am I in? Okay, that's the basic issue we're dealing with here. So think about the xy coordinate plane. I'm going to just draw some axes on this unit circle just to make this point clear. Here's my xy coordinate plane. Okay, that's the y direction going vertically, and this is the x direction going horizontally. And remember that sine and cosine correspond to certain coordinate pairs, or certain coordinates. Sine is kind of like your, this is your y coordinate, and cosine is your x coordinate, assuming you're on the unit circle. That's an important assumption. You have to have a hypotenuse of 1 on all of these triangles, and then you're on the unit circle, and you can make this assumption right here, that sine is just the y value and cosine is the x value. Now, if you look at your unit circle, let's try to talk about these x and y values. Okay, if I said to you, I'm in quadrant 1, what are my x and y values right here? Well, everyone knows that x is positive and y is positive in quadrant 1. But what that means, as far as the unit circle is concerned, is the sine of theta is positive and the cosine of theta is positive in quadrant 1. In quadrant 4, for example, that's y equals negative numbers. So sine of theta is negative. But cosine of theta is still positive because we still have positive x values. Okay, and you can play this game all the way around the unit circle for quadrants 2 and 3. Okay, hold on. Let me not mess this up. Okay, let's move the whole thing. Of course, that's going to mess that up. Good gracious. I'm just going to work over here. Quadrant 2, let's talk about that. X values are negative. Okay, so cosine of theta is negative, and sine of theta, because it's y values, sine of theta is positive. And here for quadrant 3, both x and y are negative, right? I'm in the bottom left, so sine of theta is less than 0, and cosine of theta is less than 0. And if you've memorized your numbers from the unit circle, you actually already know this. Maybe you didn't see the connection with the plus minus signs, but let's walk through this example down here and fill in the table. X coordinate negative, y coordinate negative. You don't even need to know where on the unit circle exactly this is. As long as you look at the negative signs, you can figure out this is quadrant 3. Now, if you have a positive x coordinate, where might I be? Let's use blue, okay, for this guy. Positive x coordinate, that means I'm somewhere over here, right? I have to be in either quadrant 1 or quadrant 4. But then it tells us that you're in quadrant 1. So now we know that the x coordinate is radical 3 over 2, and I must be in quadrant 1. That's right here, okay, where the y coordinate, this value, is equal to 1/2. Okay, so that's 1/2 right there. All right, let's do another example. Let's see which one of these looks like fun. Let's do this last one. Okay, now let's move over to, green. Negative 1/2. That's a negative value. So that means I must be somewhere in these bottom two quadrants, either 3 or 4. And the table tells us, use quadrant 3. So now, focusing on quadrant 3, the y coordinate is negative 1/2. That puts me down here. And that means the x coordinate, okay, remember the x coordinate is the horizontal one, and that's long. If you remember short versus long in the unit circle, this is going to be negative square root of 3 over 2. Okay, and you can fill in the whole table that way, just with this argument of what's positive, what's negative on the unit circle.